Hello friends, this is Yogesh Popat and today again we are here with a very interesting topic which plays a very significant role in physics, that is charge. Charge is very much important for our day-to-day life also. Without charge we cannot imagine our life. So the different positions of charges produces the different effects, and that's what we are going to discuss today, that is electrostatics, magnetism and electromagnetic wave. How the different position of the charge produces the different fields, the different streams of physics. I have a very simple demonstration also to show you the portion of electrostatics. We'll have a detailed discussion on this maybe in the later stage. So if we see here, I have written here, the charge plays a very important role, and there are three different positions of charges, or three different kinds of the situations of charges may take place. First is when the charge is at rest. You must have heard about the field of electrostatics. Electrostatics is made up of the two words. This word can be split into two parts: electro and statics. Electro, that means something related to the electric field, and static, that means the position of charge is at rest. So whenever the charge will be at rest, then that field or the study of the charge at rest will be termed as electrostatics. Whether you discuss about electric field of the charge, whether you discuss about the potential of the charge, whether you discuss about the charge density of the charge, whether you discuss about the different properties of charges. When the charge is kept at rest, it does not produces any magnetic effect. It produces only the electrical effect. When the velocity of the charge is zero, that means the charge is at rest. That field is called electrostatics. The study of the electric field, the study of potential, the study of charge density, or the study of different properties of charges. That complete things comes under the part of electrostatics. In the static condition, in the rest condition, the charge does not produces any magnetic effect. It only produces the electric effect, or you may say it as electric field. When the charge is at rest, it does not produces the magnetic field. To show the part of electrostatic, I have one simple demonstration where I have this ear muffs which we generally use in the cold days during winters, and I have this PVC pipe. Now what I'm going to do, I'm going to rub this pipe with this muffs. So when I rub it, the frictional electricity takes place. Due to friction, this pipe gets charged. Okay, so what I'm going to do, I'm going to rub this and I'm going to see the effect of this charged body to that balloon. Yeah, how this charged body is going to affect that balloon, the position of that balloon. This is just a woolen part, you may consider it as a fur. And what I'm going to do, I'm going to rub it very properly so that this PVC pipe gets charged. If this pipe is replaced by a glass rod, it would have shown a little better effect, but right now I have a PVC pipe with me. And if you see here, just observe the change in position of the balloon. A very little movement takes place towards the rod. I will try to get it more charged. You can see when I'm bringing this rod or pipe towards the balloon, it is moving towards the metallic rod. So the demonstration indicates that when I rub this rod Suppose I have rubbed this portion of the rod. Since this is a PVC rod, not a metallic rod, so the charged particle accumulated or induced in this portion, whatever portion I rub, this is not going to distribute uniformly throughout the pipe. I can show you with the help of diagram also. Suppose this is the rod and I have rubbed only this part. So in this there may acquire positive or negative charges. It depends on the work function. In the next class we will have a discussion on the work function. Either positive or negative charges accumulates in this pipe. So these charges are not going to be distributed uniformly, but if it becomes a metallic pipe, after rubbing these charges will uniformly gets distributed throughout the surface, throughout the structure of the metallic pipe. So in both the cases the charges are at rest, they are not moving anywhere, so it will have the electrical effect, it will have its own electric field, it will have its own potential, it will have its own charge density at rest when the charges are at rest. So the field of physics in which we discuss about the different properties of charges, electric field, when the charges get kept at rest, that field is called electrostatics. And in electrostatics, the static charge does not produce any magnetic effect, it produces only the electrical effect. But when the same charge moves with a constant velocity, it produces magnetism, the magnetic effect around it. You must have watched my video on magnetic effects of current, Oersted experiment you must have watched, solenoid you must have watched. So in that demonstration I have shown you that the current carrying conductor produces a magnetic field around it. Suppose if there is no DC supply applied across the ends of the conductor, in the entire magnetic effects I have not connected any AC supply, I have connected only DC supply. So if there is no connection applied or any potential applied across the ends of the conductor, the direction of the motion of the electron will be very random as shown in this diagram. So there will be no net effect or there will be no net direction of the movement of the electrons. That's why it doesn't constitute any current. And if you see this as a conductor, it is electrically neutral because it has same number of protons and same number of electrons. So it does not produce any electric field also. When there is nothing is connected, it does not produce any electric field, it does not produce any magnetic field. I am talking about the electrons inside the conductor. But as soon as I connect the DC battery across the ends of the conductor, the electron will start moving by experiencing the repulsive force, but by this negative terminal, negative, and the charge of the electron is negative, so negative will repel each other. So these electrons will move from negative to the positive terminal, and the conventional direction of current, we know that it is from positive to negative. So the direction of electron and the direction of current will be opposite to each other. And when the electron moves, all the electrons moves in a certain direction, in a particular direction, it produces the magnetic field. We have applied here a DC supply so that the electrons moves with a constant velocity. Velocity is constant, that means there will be no acceleration. The charges cannot get accelerated because the velocity is constant. So when the charge moves with a constant velocity, that is a non-zero velocity, that means zero acceleration, then it produces the magnetic effect. But when the charges are inside the conductor, inside the specimen of the conductor, it does not produce an electric field. But if we talk about a single charge, we are not talking about this specimen, we are talking about only single charge, either proton or electron, whatever. So in this specimen, since it is electrically neutral, if the electrons are moving also, if one electron is entering this end, so the other electron will leave from this end. So overall, this conductor will become electrically neutral. We cannot say that if the charges are moving or the electrons are moving from one end to the other end, so this conductor becomes charged. No, this is a misconception. The conductor does not get charged, only the electrons are flowing in a particular direction, in a certain direction, due to the application of this DC supply. But when we talk about a single charge, either positive or negative, whatever, so it will have its own charge. That means it is not a neutral element, you may say. It is not a neutral. The charge is not neutral. Either it will be a positive charge or it will be a negative charge. We are talking about only single charge. So when a single charge moves with a constant velocity, it produces electric and magnetic field both. But when we talk about the conductor, when the conductor conducts, it only produces the magnetic field, not the electric field. Two different things are there, my dear students. One is the electrons are flowing inside the specimen of the conductor where the positive ions are also there, which makes the conductor neutral. And one is only single charge. Just to you try to differentiate between these two conditions. One is a single charge, so it will have certain amount of net charge. When there exists a certain amount of net charge, there exists electric field, and since it is moving with a constant velocity, it produces magnetic field also. So simply you may say, when the charge is at rest, that field is called electrostatics, where we discuss different things about the static charge. When the charge moves with a constant velocity, it produces the magnetic field. Okay, the acceleration is zero. Now the third case, when the charge moves with a variable velocity. So when the charge moves with a variable velocity, that means with certain acceleration, the accelerated charge, you may say. Variable velocity, that means acceleration will not be zero. The charge will have some acceleration. Okay, so when the charge will have some acceleration, it gets accelerated and it produces electromagnetic wave. Now what is electromagnetic wave? Electromagnetic wave or electromagnetic energy is a kind of energy or a wave which consists of both the components, electrical component and magnetic component both. And both the components are mutually perpendicular to each other. I have drawn this here. You just take three axes x, y, z, that is a three-dimensional coordinate system. If we take this red part, I have taken this red part which is vibrating or oscillating along the y-axis like this. And this z part is, this electrical component part is vibrating along the z-axis. The structure will be like this. Okay, so you take it as y-axis and this is suppose the z-axis. So magnetic component is vibrating along y-axis and the electrical component is vibrating along the z-axis, and in the third direction the wave will move. So you can see here very clearly the red component indicates the magnetic field vibrating along the y-axis. Electrical component is vibrating along the z-axis and the wave will move in x direction. That means electrical component, magnetic component and direction of propagation, all these three are mutually perpendicular to each other. You may see here magnetic field is along y-axis I have taken, electric field is along z-axis I have taken. So the dP stands for direction of propagation of the wave, it is along x-axis. You may change the axes, you may take the vibration of electric field on x, you may take the vibration of electric field on magnetic field on y, then the direction of propagation will be z. Okay, so electromagnetic wave is a wave which is produced by the charge moving with a variable velocity. That means it is an accelerated charge, and the electrical component and the magnetic component are mutually perpendicular to each other, and the direction of propagation, indeed it is mutually perpendicular to the direction of oscillation of both the field, electric field and magnetic field. Now what is the reason why this accelerated charge produces electromagnetic wave? There is a reason for this also, why the charge moving with a constant velocity produces magnetic field, but for that we have to study the theory of relativity. That is not the part of your curriculum in class 9th or class 11th or class 10th or class 12th. So I'm not going to discuss that. We will have a separate discussion on that theory of relativity, but there is a mathematical reason. But I don't want to bombard you with that mathematical derivation. So you can understand in this way only till date. Here I have not written any formula, I am just telling you the concept. The electric field and magnetic field both are the function of velocity, both depends on the velocity. Okay, here we have seen that when the charge moves with a constant velocity, it produces electric and magnetic field. Maxwell's equation also says, we have studied in electromagnetic induction, the changing magnetic field produces electric field. Similarly, the changing magnetic field produces electric field and changing electric field produces magnetic field. Both are dependent on each other as per the Maxwell's equation. So here you can see, if a charged particle is moving with a variable velocity, and if it is a single charged particle, definitely it will have some electric field. If charged particle, there is only one charged particle, if it exists, there exists electric field. And when it is moving, it definitely produces the magnetic field. Okay. Now, if it gets accelerated, what will happen? What is the difference between this case and this case? Okay. Here the charge is not accelerating, but here if you see this diagram, Q is here. If it attains a velocity v, then after certain instant, since the velocity is increasing, that's why it gets accelerated. Only when the velocity changes, then only we'll say the charge is accelerated. So at certain instant it becomes v plus v, then it becomes v plus v plus v, then it will becomes v plus v plus v 4 times v. So in this way it is get accelerated, charge is accelerated. So up to this point the electric field and magnetic fields are produced because it is moving with certain velocity. Now what about the extra energy v plus v, that is 2v, v plus v plus v, 3v, 4v, 5v and so on. V stands for velocity. So these extra velocities or these extra energies, when velocity is there and definitely the charged particle will have certain mass. So when the particle have a certain mass and it moves with certain velocity, it will definitely have some kinetic energy. And that energy is pushing the particle in forward direction, and that's why it forms a wave. That's why the accelerated particles forms electromagnetic wave. Accelerated, that means velocity is increasing. Once the charged particle is set with certain velocity, it will automatically produce the electric field, and that oscillation of electric field in turn produces the magnetic field. That means here the electric field and magnetic field are producing each other. They are interdependent as per the Maxwell's equation. Again I will be repeating, as per the Maxwell's equation, changing electric field produces magnetic field and changing magnetic field produces electric field. But in this case, if you see for electromagnetic wave, this is the relation, C is equals to E by V. The C stands for the speed of electromagnetic wave. Light is also a kind of electromagnetic wave. The speed is 3 into 10 to the power 8 meters per second approximately. So C is equals to, here C stands for 3 into 10 to the power 8 is equals to E by V. Here you can see this B gets multiplied here. So I will just write B here. So electric field is equals to B times 3 into 10 to the power 8 meter per second. From here you can see. Electric field is 3 into 10 to the power 8 into B. That means magnetic field times 3 into 10 to the power 8 is the strength of electric field. Okay. So here we had a discussion that if the charge is at rest, the field will be called as electrostatics. The branch of physics will be termed as electrostatics. Statics means at rest, where we discuss about the different properties of charges, electric field, potential, density, etc. When the charge moves with a constant velocity in a conductor, it produces only magnetic field, but a single charge will have magnetic as well as electrical property. Electrical field and magnetic field, both it will produce. But when the charge moves with a changing velocity, that is accelerating charge, produces electromagnetic wave. Now the reason why they produce electromagnetic wave, because both the fields, electric field and magnetic field, depends on the velocity, and since the velocity is changing, and as per the Maxwell's equation, the electric field produces magnetic field and the magnetic field produces electric field, so they are interdependent. And since the velocity is changing, so definitely E and B will also be changing, and the changing field produces the other field. Changing electric field produces magnetic field, changing magnetic field produces electric field. Here V is changing, that's what I have written here. So since V is changing, E will change. Changing E produces B, that is magnetic field. V is changing, so B will change, and changing B produces E. So both of these are interdependent. They are oscillating. So the oscillating charge produces electromagnetic wave. I hope that this lecture is very much clear to you. The extra velocity or the extra velocity component, the accelerating velocity component pushes the charge in a forward direction to form a wave. That's why we call it as electromagnetic wave. Okay, I hope that this part is very much clear to you. This is very important and this is a very general topic. Anyone can watch this video class 8th onwards. Okay, so thank you so much. See you in the next class.